This is the review for the midterm. It says write an equivalent multiplication expression, then find the quotient in its simplest form. Use a model to support your answer. Okay, so that says 1/4 divided by 2. And what it means by writing a multiplication expression, that's the same thing as keep, change, flip, right? But the problem with 1/4, the problem with 2 is that's not a fraction, right? Or is it? How can we write 2 as a fraction? It would be 1/4 divided by 2/1. So to write that as a multiplication, we would say that is the same thing as 1/4 times 1/2. And that would be 1/8. Multiply straight across. Okay? Now, the second one there is 2/3 divided by, and we're just going to write that as 6/1. That's the same thing. That is the same thing as 2/3. Remember, you always keep the first one, change the symbol, and flip the last one. So that's 2/18, but we have to put that in its simplest form, which is 1/9. And that's what everybody got, correct? Now, Henry bought 4 pies. Oh, let's do a model for these. Yep. We need to do a model first. So, if we divide 1/4, okay, by 2, how much is each one now? Correct. Each one is 1/8. We have 1/8. Now let's do 2/3 divided by 6. Okay. Now if we divide all that by 6, that's going to be hard to do for me on here. Let's try it. There we go. Now how much is this? Right here. 2/18 or 1/9. Correct. Because we were talking about 2/3. All right. Now Henry bought 4 pies, which he plans to share with a group of friends. If there is exactly enough to give each member of the group 1/6 of the pie, how many people are in the group? Well, we would take 4 pies and divide it by 6, right? So 4 divided by 1/6, that's the same thing as 4 times 6, which is 24. Now, if we modeled that, we could have 4 pizza pies. Divide that into 6. And I know those are not equal 6, but you get the point. There's 24 slices there, therefore 24 people would eat. Does everybody have that? If not, you'll have to go back and watch this video because I'm about to erase it. Start up here. All right, the next one says Rachel finished 3/4 of the race in 6 hours. How long was the entire race? Well, this is the one I would just draw it. She's finished 3/4 in 6 hours. So how much is each one? 2, 4, 6. So how long is it going to take her if she keeps up the same pace? 8 hours. Everybody see how I did that? Okay. Find the quotient. Draw a model to support your solution. All right. 9/4 divided by 3/4. Since we have the same denominator, we can just divide the numerators, right? 9 divided by 3 is 3. So now how are we going to model that? We're going to say 9/4, so that would be all of these, and then this one. Well, how many 3/4 are they? There's 1, there's 2, there's 3. There's your 3/4 groups of 3/4. Okay? Now, 7/3 divided by 2/3. We can do the same thing, just divide by the numerators. What's 7 divided by 2? 3 1/2. How can we model that? Well, we can draw 7/3. Which is all of this and here. And we're dividing that into 2/3. So we have 1, 2, 3. And then we only have one of the 2/3. One of the 2/3. So we only have a half. So we have 3 1/2. Okay? Now, here we go with writing a story problem again. Write a story problem using the measurement interpretation of the division for the following. 3/4 divided by 1/8 is 6. So, what is your story, Celine? Okay. Because Chloe didn't give the whole pie to everybody. She took 1/4 and put it in the refrigerator. Then she said, I'm going to split this 3/4 between my 8 friends. So how much of the pie, how much of the slices can they have? They can have, or I can give them to 6 friends. So write a story problem using the partiative interpretation of the division for the following. So this says 25 divided by 5/8 is equal to 40. So what we would say there is kind of like the Rachel finished 3/4 of the race. That's the kind of the exact same type of division problem. So we could say that Jim finished 5/8 of a race and he had went 25 miles. How far is the race? It would be 40 miles if he had finished 5/8 and had already went 25. All right. Page 2. What does it mean when we say the reciprocal? Not the opposite. Opposite's when we put negatives in front of it. Reciprocal means to flip it. Reciprocal means to flip it. So if the number is 7/10, what is the reciprocal? 10/7. If the number is 1/2, the reciprocal is 2/1 or 2. What's the reciprocal of 5? 1/5. Good, because we can write 5/1. So if we flipped it, it would be 1/5. Now it says, rewrite the division expression as an equivalent multiplication expression. Same thing. That is 5/8 divided by 2/3. 5/8 divided by 2/3. We're going to make that equal to 5/8 times 3/2. And that's 15/16. And that is in simplest form as well. You see how that works? Okay. 3/4 divided by 5 1/5. Still not charging? Let's see here. Somebody tell me their answer here. Say it again. 15/108. The answer is 104. All right, so what did you do? You should have turned that into an improper fraction first. Okay? So let's say 3/4 divided by 5 times 5 is 5 times 5 is 25, plus 1 is 26/5. Now we're going to flip that. Okay. Now can we reduce any of that? Don't look like it. So we have 15/104. Okay. Let's go ahead and change this one into an improper fraction as well. Sorry, hold on one second. Okay. 5/8 divided by 6 times 6 is 36, plus 5 is 41/6. Can we reduce those? Don't look like it. 205/48. 15/100 and what? Hold up. I didn't flip it, did I? I got to flip it. So that was 41/6. So now we got to flip it. Yeah, we can reduce these now. This will reduce down to 4, and this will reduce down to 3. So that's 15 over 164. All right, one more. We'll do it down here. 3/7. It's not reduced to the simplest form. It'll reduce even farther. Okay. Which is 5/2. So we got to flip that. That's going to be 6/35. Everybody got that? Okay. Now, this says solve each problem, show that the placement of the decimal is correct through either estimation or fraction calculation. Now, we can make this first one, 594, we can turn that fraction into what? Something over 100, right? But since it's to the denominator is the 25th, all I have to do is multiply the top and the bottom by 4, and I make it over 100. So 7 times 4 is 28 over 100 plus, and we can just leave the other one by alone. So 594 plus 89 is 683. 28 plus 37 hundredths is 65 over 100. And we'll just leave it like that. You could reduce that, because both would reduce by 5, right? And what would that be? Let's go ahead and reduce it. 683, that'll be, is that 13 over 20? 17? 13. 13. 65 divided by 5 is 13. Okay? Now, to do this next problem, we would say what? That would be 382.3 minus 191.87, right? And can I put a 0 there? Yeah, we can always put a 0 at the end, right? So now we could just subtract that. It is subtraction, yeah. Borrow. As long as we keep our decimal lined up, we should be fine. Everybody get 190 and 43 hundredths? All right, good. All right, I'm going to start erasing this up here, guys, so we can do some more. All right. This one says, calculate the product. Use estimation or fraction multiplication to determine your answer. if your answer is reasonable. So, calculate the product. How many decimal places will they be in our answer? 4. That's the main thing on this problem, is checking to see if you know how many decimal places there will be in your answer. Does everybody see why there will be 4? Okay. What is the answer that you got? Say it again. Say it again. Hold up. 2,000. 4758? 2758. Well, let me just see here. 78 and 9300. And what did you say? Should be 85. You're correct. 85. That should have been your answer if you multiplied all that out. But the thing is knowing that you have 4 decimal places, okay? Now, paint costs $29.95 per gallon. Nikki needs 12 and 25 hundredths, or a quarter of a gallon, to complete her painting project. How much will Nikki need? How many decimal places will they be? In your answer? 2. Why? Because this says round to the nearest penny. Yes, if you were to multiply that all out, there's 4 decimal places. But in your answer, you should only have 2. You should round it to the nearest penny. Okay? So, yes. Mm-hmm. So if you were to work this out, you would get this answer. But for you to round it to the nearest penny, you would have $366.89. Okay? Now, round to estimate the quotient. So there's a couple of different ways you could do this. 4,732 divided by 13. I would probably round that to 4,700 divided by 10, which is going to give me 470. That's one way of rounding it. Simple way of rounding it, right? Now, this one is 22,752. You could round that to 20,000 and divide that by 20. And you would get 1,000. The other ways you could have done that, you could have divided by 23,000 divided by 20, but I just tried to make it as round as possible. Okay? Now, this next section, we're only determining whether it is even or odd without calculating. So that means don't put it into a calculator. Just look at it and tell me. Because all we're cared about is the unit place, or the ones place, right? So if I add an even number, if I add an even number to an odd number, what do I get? I get an odd number. So number 1, I'm going to write it off over here to the side. 1 is going to be an odd answer. Now, if I multiply an even number and an even number, what do I get? I'm going to get an even number. Number 3, if I add an odd and an odd, I get a even. Number 4, if I multiply an odd and an odd, I get an odd. 1 times 7 is 7, which is odd. All right, now it says show or explain why 12 plus 13 plus 14 plus 15 plus 16 results in an even sum. Well, we have an even plus an odd, an even plus an odd, plus an even. Since I have 2 odds right here, when I add 2 odds, I get an even. And then if I add by more evens, I'm going to keep getting evens, right? So that is why that would be an even. An odd plus an odd is equal to an even. And if I plus evens, those equal evens all the way. Okay? Now, page 3. This is our divisibility rule. Is 26,341 divisible by 3? If it is, write the number as the product of 3 and another number. Janice says no. Why do you say no? What is your rule for being divisible by 3? All right, what's the sum of the digits? 2 plus 6 plus 3 plus 4 plus 1 is 16. Is 16 divisible by 3? No. Therefore, it is not divisible by 3. Is 8,397 divisible by 9? Well, what's our rule for being divisible by 9? If the sum of the digits is divisible by 9, well, 8 plus 3 plus 9 plus 7, that's 11 plus 16, which is going to be 27. Is 27 divisible by 9? Yes, it is 3. So 3 is the other factor. 9 times 3 is 27. Now, this says find the least common factor and the GCF for 12 and 15. Least common multiple means to multiply. So 12 times 1 is 12. 12 times 2 is 24. 36. We're going to list all these multiples out through here. Now let's look at 15. What is 15? 15, 30, 45, 60. Now I can stop because I have the least common multiple is 60. Does everybody see how to do the least common multiple? Now to find the greatest common factor, we have to list the factors. So how do we come up with 12? 1 and 12. 2 and 6. 3 and 4. Now that's all of them. How do we come up with 15? 1 and 15. 3 and 5. And that is it. So we're going to circle all the common ones. Which one's the greatest? 3. 3 is the GCF. So we could do that as 60 and 3. The GCL LCM. Okay? Everybody understand that? Now we got to be, oh wait, we still have one more. Find the greatest common factor. So we're going to do the factors of 42 and 70. Let me erase these. All right. Factors of 42. 1 and 42. 2 and 21. Is it divisible by 3? Well, of course it is, because 4 plus 2 is 6. 6 is divisible by 3, so 3 and what? 14. You got a question? What? Oh, you want to use Euclid's algorithm? Well, tell me how to do that then. Sure. That is a way to find the greatest common factor. How can you do that? You say 42 will go into 70 how many times? One time. That is 42, which gives you 28. So then we're going to say, how many times will 28 go into 42? One time. What is 42 minus 28? What is 42 minus 28? What? 14. How many times will 14 go into 28? 2. Therefore, what is the greatest common factor? 14. Good. I like Euclid's algorithm as well. It's easy. It's quicker. Or factor tree? I don't like factor trees. But go for it. If that's what you like, that's what you feel better with, go for it. Okay? What? When you do the factor tree, you're finding the prime factorization. Don't worry about it. Okay. Here we go. Greatest common factor. Oh, well, no, let's see what A wants. There are 18 girls and 24 boys who want to participate in a trivia challenge. If each team must have the same ratio of girls and boys, what do the greatest number of teams that can enter? Find how many boys and girls each team will have. Anybody got their answer for these? Let me erase these so I can write them down so everybody can have them. What? It's just a questions. Bunch of questions. All right, what'd you get, Celine? Three girls and 4 boys per team. Correct. And you would have gotten that by listing out the factors. So 6 times 3 and 6 times 4 is 24 for the boys and 18 for the girls. So that's how you got those numbers, right? All right, that is A. B says the ski club members are preparing identical welcome kits. The ski club has 60 hand warmers of packets and 48 foot warmer packets. Find the greatest number of identical kits they can prepare using all the hand warmers and foot warmers. How many hand warmer packets and how many foot warmer packets would each welcome kit have? Well, let's do this one. We're going to do the factors for 48 and the factors for 60. Well, that would be 1 and 48, 2 and 24, 3 and 16, 4 and 12. 5 won't work. Will 6 work? Yes, because it's divisible by both 2 and 3. So 6 and 13. Oh, 8. Sorry. Crazy. 6 and 8. And that would be it. So 60 is going to be 1 and 60, 2 and 30, 3 and 20. Will 4 go into 60? 4 go into 60 how many times? 15. 6 will go into it how many times? 10. And that's... Oh, I skipped 5, didn't I? 5 and 12. 6 and 10. That's it. Okay? So, what's going to be our greatest common factor? 12. Okay? So, we're going to have 12 packets, or I'm sorry, 12 kits with 4 foot warmers and 5 hand warmers. Because there was 4, the 48 is talking about the foot warmers, and the 60 is talking about the hand warmers. Okay? 12 kits, 4 foot, 5 hands. Everybody understand how we did that? All right, so what was the answer for C then? Right, but what's the answer for C? The answer is 5. How many senators? 20 senators and 87 representatives. Yeah. 5 groups. Senators, there'll be 20, and representatives will be 87. Now, find the least common multiple of, is that 4 and 30? You just multiplied them together. Can't always do that. Okay? So we would just say 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60. And then for the 30s, I would say 30, 60. Boom, boom. There's your answer. 60. Okay? For the least common multiple of 4 and 30. Everybody say that? Okay? Now, this wants us to find hot dog packets. Hot dogs come packed in 10 in a package. Hot dog buns come packed 8 in a package. If we want 1 hot dog bun for each bun, 1 hot dog for each bun for a picnic, with none left over, what is the least amount of each we can buy? how many packages of each of them would we have to buy? Okay, so we're talking about 10 and 8 here. The easiest way to do these is start, I've told y'all this before, start with the biggest number and go 10, 20, 30, 40. Now I know that 8 times 5 is equal to 40, right? So that's going to work. And 10 times 4 is equal to 40. So I'm going to have 40 hot dogs with the buns, right? Which means I have to buy 4 packs of hot dogs and 5 packs of buns, right? So 5 buns and 4 hot dogs. And I'm going to have 40 of each. Not 40 of each, but 40 combined. 40 with the hot dogs and the buns together. Okay? Now, starting at 6 a.m., what's the answer for B? Who got the answer for B? 1 hour later. Everybody know how to do that? List the multiples, and it's going to be 60 minutes. So we would just add 1 hour to the time. All right, C. What do we get for C? I didn't hear you. 20. 120? Yeah, I believe it's going to be 120. Use prime factorization to find the greatest common factor. This is an example of prime factorization. I don't care if I ask you how to do it. I don't care how you find it. Whether you use prime factorization, Euclid's, list the factors, list the multiples, I don't care. As long as you can find those answers. Okay?